Thank you all for coming here. My name is Alina. I'm developer advocate for GraalVM. I'm happy to see you here. Certainly, I did not expect this session to make it to the list of top most anticipated talks today, but I'm happy that you showed up. So in this session, we'll talk about some of the opportunities to optimize your application performance and how you can use GraalVM to achieve that. So why GraalVM? Why are we talking about it in this session, and what exactly can it do for you? So GraalVM is a universal virtual machine. Universal because it can run a bunch of different languages, and it also has this mission to run programs written in different languages really fast. And in fact, it's quite a big and complex project, and there are many things that you can do with it. So first thing is that you can have high performance for abstractions of any language. And we think this is important because some of the languages out there do not really have this high performance, so we would like to give it to them. Another thing here is that sometimes performance is considered to be a trade-off with abstractions, meaning if you write good abstracted code, some people think that it will not be really fast, or if you want it to be fast, you need to write it in this performance-aware manner. Well, we think that it's not necessarily has to be the case, and you can give this optimizations to your underlying platform, a VM in our case, and we can do this automatically for you. Another thing that GraalVM can do for you is introduce this new operation mode for Java and JVM applications, in which you can compile them ahead of time into native binaries, so they can start really fast and don't need that much memory as compared to traditional setup. So these two things we'll be talking about most of this session today. One more thing is, since there are multiple languages already implemented on top of GraalVM platform, you can use different languages in your application, or in case you have your own custom in-house language, you can also implement it on top of GraalVM platform and get access to the common tooling and optimizations and interop with other languages. And the last one here is that it can be easily embeddable in various environments, and this way bring these languages and features to those environments. So this is a high-level overview of what GraalVM can offer for you, and you see that there are quite a lot of things happening here. So on top here, there are languages which you can use in GraalVM, and below are the platforms in which you can use it. So as you can see, you can run your normal Java JVM applications on top of GraalVM that will be in the context of OpenJDK here. So we are talking about normal JIT way of running your applications, no any migration efforts needed from your side. It just works out of the box. One more thing here is JavaScript. So we have also a JavaScript engine. It's called GraalJS. So you can run your JavaScript code fast, and this engine is also highly compatible with the ECMAScript standards. The same goes for Ruby, and also if you are interested in things like statistics and data processing, machine learning, you might be interested in languages like R or Python for that. The last one here is that we have an LLVM runtime, so you can also run languages like C, C++ on top of GraalVM. So talking about platforms, I already mentioned OpenJDK. The same goes for Node.js, so you can run your unmodified Node.js apps on GraalVM. Quite an interesting case is that you can use GraalVM in a database, and this way have access to those languages and features right in your database. And the last one is a standalone mode where GraalVM is the only platform and runtime you need to run your application. So that is this ahead-of-time compilation native image mode. So as you see, there are multiple languages, and an interesting fact about it is that recently we had this poll on Twitter, and we asked people what is the most kind of interesting and exciting GraalVM language for you. So how do you think which one of those languages won that? You can just shout out versions. I mean, they're all here.
Python.
Python? Why Python?
It's just very popular.
OK. Yeah, so yeah, technically we did not include Java and JVM languages because, first of all, it wouldn't be a fair competition, right, if you included those. And second is because on Twitter you have a very limited list of options for voting. It's only 4. So in fact, this gentleman over here is right. My personal bet was on JavaScript. Somehow I thought it will win, but in fact, Python won. So it's not that, yeah, it's just an interesting case. It's not that it's the main language or the only language that you can run on top of GraalVM, but it's a nice and interesting feedback from our community about the popularity of those other languages on top of our platform. So production ready, that was a huge milestone for us. It was May last year because GraalVM originated in our R&D department, Oracle Labs. So it was a massive scientific research project. And right now it's also production ready, so you can safely use it in your production environment. And also it comes in 2 editions. So there is community edition, which is open source, free to use. Development is happening on GitHub. You can track it, see what's under the hood. And also we have an enterprise edition, which would require for you to have a commercial license to run it in production, but it's also free for things like evaluation purposes, doing proof of concept, this kind of things. And you can get both of them from graalvm.org. That's the main entry point for all the things GraalVM related. And since I mentioned already that this is quite massive project, I wanted also to share this kind of infographic with you. So these are different repositories that contribute to this big main repository. So you see that we have kind of core repository which has compiler and language implementation API, things like that. Also, we have language implementations and tools, and they all contribute to this massive repository. So talking about performance, I think that you heard enough about it on this track. I want to also offer one more way to look at it. So from compiler perspective, you might be looking at all kind of different things. One thing perhaps you always think about when you optimize for performance is peak throughput, right? So that's #1 metric most of the people care about. Or also optimizing for reducing max latency. One more thing that you could be looking at is actually startup speed, because this may be important in your cloud and microservice environment, or for example, when you want to scale, this may be something you will be most interested in. Another thing, and it was also mentioned at this track today, so you can be also optimizing for reducing memory usage, because specifically in cloud environments, it might be something your cloud vendor will be charging you based on. And the last one, well, it's less, I would say, priority for server-side deployments, but also in some cases, in some devices, you might be looking at small packaging size of your application. And we'll compare later on in this presentation how different mode of operation of GraalVM can help you optimize for either of those metrics. So talking about performance and what you can do for your Java application with GraalVM, this is a #1 slide and decision that you need to make if you're considering migrating to GraalVM. Because GraalVM can work with your Java application in 2 modes. It can do JIT, meaning dynamic compilations, like you normally do with your JVM, or it can compile a Java application into a native image. And this way, they will have very different performance benefits and trade-offs. So to compare those 2 closer, let's take a look at what GraalVM native image actually is. So it's your Java program that has been compiled ahead of time into a native executable. And since it no longer needs a runtime, Java runtime to run, it can have this startup and memory benefits. And also interesting thing about it is that it is compiled using the same compiler that is working in JIT mode. So with this compiler, you can do really both things. So how do they compare and why they are so different in terms of performance? So when you run your Java application in JIT mode, meaning dynamic compilation, there is quite a lot of things happening. So as you see, first your code is loaded, then it's verified, interpreted, profiled, compiled, and there is quite a lot of operations, and also they're quite expensive for your machine to run those. With GraalVM native image, things are slightly different. So you can think of it as of working with your application in 2 phases. So first you have the build phase, where you build your native image, and then you can run it when it's ready. And the idea here is to move all the heavy lifting, all the expensive operations to image build time. So you can do it once, do all those expensive operations, and afterwards you can start really fast every single time you actually run your application. So how it works inside and how it is actually possible to compile Java ahead of time. So what happens is that we take your application, and when you run our native image command, we start analyzing your application, starting from its main entry point. And we look for all the code that is reachable, and we also run initializations so we can perform heap snapshotting. So you can start with a pre-populated version of your heap. And we repeat those 2 operations until we see that the fixed point is reached. So we see all the code that needs to end up in your application for it to be possible to run. And then when we have it, we optimize it and we compile it into this native executable. So how does it affect startup? So as we've discussed, when you look at what happens when you first run your application in JIT mode, there is quite a lot of those operations happening. And they need to happen so that your application can run. Of course, here is another trade-off. Then once you've done all of that, your application can really go really fast for quite a long time. But if for your project, startup is more important, then all these warm-up operations might not be that important and that relevant for you. On the contrary, in IoT mode, what happens when you actually start your application is just your executable needs to start, and then you can immediately run this code that was already optimized at the image build time. The same goes for memory. So if you compare what happens to memory and how much memory you need in both of those modes, you see that in JIT mode, you need to keep around a lot of memory for all those structures. So for the JVM executable itself, for application data, for metadata stuff. Once again, with IoT, you only need to load your application into memory and keep around application data, but that's basically where this time and memory differences are coming from. So if you go back to our performance metrics and now take a look at how those two compare, you will see that JIT, and I guess all of you know it, yeah, so JIT system, meaning running on hotspot VM or GraalVM in JIT mode, is really good for optimizing for those two things. IoT, on the contrary, is quite different, and you see that it's kind of a trade-off, and based on your preferences and your priorities, you can really choose for which of those you want to optimize. So based on your project goals, based on what things matter most to you, you can really optimize for either of those. So let's see how it works. I have a demo application here, and not this one, this one. So I'm running GraalVM. So first I will run it in JIT mode. OK, so it's not really fair because I was preparing for my session and I ran it a few times, so it's a bit warmed up. But when it's really cold start, I think this time it was around 3 seconds, but usually it's about 2 something seconds. It's in JIT mode. So it's up and running. Let's see what it actually does. So it basically returns me a random conference name. So that's in JIT mode. Let me kill it and just make sure that it's actually dead because I want to reuse it. Yeah. So I actually have it compiled already too. So all these files, those are my compiled native executables. And when I run it like this, you see, well, this one is warmed up a bit too. Once again, I tried already too, but the cold start was about 100-something milliseconds. So comparing to 2 or 3 seconds, that's much faster. Let's just double check that it does the same thing. Yeah, you see that functionally they are equal, but there is this significant startup time difference. So we are talking about time to just start your application. But what if you wanted to kind of go deeper and understand more about the startup behavior of your application? So I can also measure how much resources it needs to start in every scenario. So for that, I have those scripts. So in JIT mode, you see that it started, spent some time to do it, and in terms of CPU usage, it used this number of CPU time. If I apply the same measurement technique to my compiled native image, hopefully it will be much faster and wouldn't need that much resources. Yeah, it is. So you see that it also doesn't need that much CPU because we already optimized everything at the image build time. But that's CPU. So I also talked about memory. So how can we compare memory usage for both of this? I can use for that a tool called PS record, and it will observe and will output for me CPU and memory usage, and it will I will send 3 requests to this application to have data and see how it is performing in both modes. So you see that we got our server up and running, we have sent those requests, and let's see the image. Okay, so what's the time? Looks like that's it. No. Yes, sorry, 1 second. Yeah, should be it. So you see here, so that's a JIT mode, right? And in red, this is CPU usage, and horizontal blue line, that is memory usage. So you see that up until 1.5 seconds, there is quite a lot of work happening. So we are starting our system, we are loading the code, optimizing the code, doing all of that heavy lifting. So let me just rename it so we can use the same thing, and now we will run it in AUT mode and see how different those metrics will be. Yes, so let's run it once again. So doing the same thing, getting up and running, serving those few requests, and the image should be ready by now. OK, so if we look at both of those, we see that here on the right, you see that its chart is much cleaner because there isn't that much work happening anymore. And also, if you take a closer look at this one on the left, you may notice that those operations at the very beginning, they are quite expensive, so we are using a lot of resources. But afterwards, those smaller spikes, these are actually valuable operations, meaning serving those requests. So this overhead work, comparing to the actual valuable work, is so much bigger and needs much more resources. So when you compare those two, you see that for a system that needs to get up and running from time to time to serve some requests and then go back down, you see that on the right, the AUT mode might be much more suitable. So that was startup and memory. Yeah. And also, I wanted to show you this infographic with a few microservice frameworks and how they compare in JIT and AUT mode. I just encourage you to look at this as a comparison of different operation modes, not comparing the frameworks to one another because they have different design and architecture and stuff. So in this light green one, that is GraalVM native image mode. And orange and red, these are traditional regular JDKs. So you see that in terms of startup time, and basically the same is also true for memory usage. With GraalVM native image mode, you can really reduce this time and memory requirements for getting your application up and running. So peak performance, what about it? Because we all know and love Java for peak performance, right? So how those two compare in terms of peak performance? So in terms of peak performance, JIT systems really have this benefit that since they have profiling information, they can really adapt to your application behavior and adapt as you go. And also, they can make those very aggressive and optimistic assumptions about your application behavior, because if those are no longer true, they can de-optimize and go back. But other than that, they can really optimize your code really well based on this information. So in IoT mode, by default, that information is not available because we are doing things in advance, meaning we don't have that information yet. So what we can do for IoT mode to get it closer to this good peak performance is that, first of all, we do handle all the cases in machine code because we, by default, cannot predict what will happen at runtime. But there are some things that can help. So for example, if you're looking at predictable performance, and I actually had one of those conversations here at this conference, so there are some cases in which you want to start with fairly good performance and keep at that level. So you're not interested in warming up, you want to start with good performance, and you want to have kind of ability to predict performance. So in this case, GraalVM native image can be really helpful for you. And another thing that can be helpful is profile-guided optimizations. So how does it work? You can observe this profile, this runtime information about your application. You can collect this profile information, and if you give it to us at the image build time, we can actually build this image with this profile information in mind. In this way, we can actually optimize for those cases that were the most relevant for your application behavior. And if we actually do that, so on this chart over here, you see that in green, that is JDK8 Java Hotspot VM. Yellow one is GraalVM native image, and the red one is GraalVM native image with those profile guided optimizations available. So you see that GraalVM native image in both cases starts with fairly high performance. So sometimes in your case, if you want to do something quickly, that may be enough for you. But if you're really looking for peak performance, you might notice that GraalVM native image with PGO, so the red line, is really on par with JDK Hotspot VM. Of course, it's slightly lower, but in most cases, that would be a significant difference for you. So you can get fast startup time, you can get really low memory consumption, but you can also optimize for very good peak performance. So as we already talked, currently this comparison JIT versus AUT is like this, but we would like to be for GraalVM native image like this, so you can really get all the performance metrics to be on maximum and not really, to have to decide on which one to focus. So that's currently something we work on. And I also want to talk to you about a bit how to get started with GraalVM native image for a project that you may be working on or about to start. So what's the best way to start with it? There are a few helpful things to do. So first of all, things like reflection and JNI and so on can be more challenging with GraalVM native image because it is built under a closed world assumption, meaning that in those cases, when you, for example, use those things, you would need to provide a configuration file for us so we can know that you want to access those things with your native image. You can do this configuration file manually, and we have instruction for that, but perhaps the easiest way is to use our tracing agent, which can observe your application behavior and output this information for you, so you don't have to do it manually. Another helpful thing, which sometimes I get questions about, so we also have Maven plugin, which you can use, and you can read about it also in this blog post. And also, a fairly easy way to get started with GraalVM native image is to go with one of those frameworks. There are multiple with them that work with GraalVM native image, and here is a quick guide to either of them. So you can go with Micronaut, and here is a guide for you to build your first application if that framework is working for you. Another one you can do is Halidon. So once again, you have a guide over here, and also my colleague Peter is also in the room. He's from Halidon team. So if you have Halidon specific questions, you can also talk to him. So I guess I don't need to introduce you to Quarkus because I assume some of you have been in this nice session by Sunny today. So he really helped me. I can skip all this part about the presentation and demo. He already did it. And one more thing which you might be interested in, and I get sometimes questions about this, so Spring Boot applications as GraalVM native image. So this is a screenshot from a conference talk by the team members. I think it was last year. So they presented current work in progress on running Spring Boot applications as GraalVM native image. So you can Google that video or maybe type that URL. In the nutshell, what you can do if you want to try running Spring Boot applications as GraalVM native images, you can go to their GitHub repository. There is this experimental project. It's called Spring Graal Native. You can get it, build it. It also comes with some sample applications that you already can build and run really fast because they're already compiled as a native image. I also wanted to show this demo for you. I hope it works. So what I have here is one of those applications. I already compiled it, and it's ready to be run. So if I run it, okay, once again, this is warmed up because I wanted to check my demos before I go on the stage. But the very first time I run it, it should be somewhere here. So yeah, it started at 0.6 seconds. So that was your Spring Boot application getting up and running, ready to do its work. So something, once again, that you can check. So just to summarize this whole JIT comparing to IoT story, when should you use either of those? Of course, that's your decision, but what we typically recommend is that you can use GraalVM native image if things like startup time and memory usage really are important for you. That could be your #1 option. In case you are looking at those more long-running applications where you need to really optimize for peak performance, you can compare those two, but it is likely that going with GraalVM JIT might be a better choice for you because for those long-running systems, having this profiling information and also dynamic compilation can be really beneficial. And I also want to talk a bit about some other languages. So in fact, there are many languages, as we've already seen, supported on GraalVM platform. And the best part is that you can use them together, but also there is this summed value of all those languages running on one platform, and it enables some interesting cases. So for example, in GraalVM, you can use JavaScript. You can run on JavaScript. We have this highly compatible, highly tested JavaScript engine. If you're interested in some particular NPM module or maybe a RubyGem or something, you can test. We have this compatibility tool, and you can see whether or not we support your library or module or whatever, and see which version are supported. And interesting case which I really like about GraalVM JavaScript engine is that, for example, if you're doing things like server-side rendering of JavaScript, so you might be interested in GraalJS, because that's something you can use from your Java application, and that's an example where we ported this application to our JavaScript engine, and you see that comparing to Nashorn, you can really get this nice speed up. Also, as you might know, Nashorn is deprecated now, so you might be looking for an option to where to switch and where to migrate to. Yeah, actually we have a migration guide, so if you are looking into migrating from Nashorn, that can be helpful for you. Also, talking about some more fantastic cases, so you can run even applications written like this on GraalVM. So this is Java code plus JavaScript code plus R, and they are all working together to output this application. And it's fairly easy to work with different languages in GraalVM. You basically just need to create this context and tell us which language is that and provide this code, and that will be all working together. Also, if you are doing R, you might be looking into GraalVM 2. We have this high-performance implementation. It's called FastR. And Python, we have implementation of Python 3. I just need to warn you that Python is more like early stage support language on top of GraalVM. So not every single Python application out there will already run GraalVM. But if you are interested in Python specifically, you can try it, and you can also talk to us about your experience if you want to share it with us. So once again, talking about fantastic stuff. So we are working with this team. They're called Gluon. So you can write your application in Java and run it on devices like iOS and things like that. And why this is interesting, so the way I understand it is that on iOS, you cannot really dynamically execute code. So this static ahead-of-time compilation that we offer really helps to bring your Java applications on these kind of platforms. And if you are doing those Polyglot applications, you might look into Visual VM as a tool to learn more about them. And we also have this collaboration with NVIDIA. So if you're interested in using GPUs from your GraalVM applications, that is already possible too. And I wanted to share a few stories because I've told so many things about different use cases of GraalVM where you can use it. So I also wanted to share with you some stories of companies who already use it and how they actually apply it to their production environments. So you might know this guy. His name is Chris. He's quite active. He speaks in many conferences. So Twitter is one of the first early adopters of GraalVM. They have been running it in production for about 2.5 years now. So if you're a Twitter user, you might have been already kind of facing it without knowing it. And since they have their workload written in Scala, that is something that where GraalVM compiler can be specifically useful, since it's able to speed up Scala code really well, but also Java code too. Another interesting case, which I also really like, is the Dutch National Police. So they have this interesting project where they do a lot of try to migrate their paperwork into digital environment. And for that, they have their Scala application. But also, they want to do some statistics and data processing for R, because that's easier to do in R. So they are just using GraalVM to run this Scala plus R thing as one thing. And also, we are using GraalVM internally at Oracle. So Oracle Cloud Infrastructure migrated some of their services from Java to GraalVM, and they reported this kind of peak performance and garbage collection times improvements. And yeah, I already mentioned the NVIDIA case. One more interesting, and that's more of recent stories. So this company, OKRU, they also using GraalVM for this case of server-side rendering of JavaScript. And they have interesting blog posts about it, how they actually migrated their system to GraalVM JavaScript engine. So project roadmap. If you're evaluating GraalVM, perhaps you would be interested in how project goes on and how different versions appear and when do you need to prepare for a newer version. So for that, we have this tool. It's called version roadmap. So on our website, you can check when the next version is going live and which kind of version is it. The latest one is 20.0. And some of the recent updates, so for quite some time we only had JDK 8-based builds, but now we also have JDK 11, so that is something you are doing, you can evaluate GraalVM too. Also, we got this request that people want to see GC improvements in native image. So right now, as of the recent release a few weeks ago, you can also try this low latency GC in GraalVM native image, which should also contribute to additional performance improvements. And yeah, in case you are an open source contributor or if you are looking to become one, we are happy to accept contributions. So that's something interesting for you. Here are a couple of ways in which you can contribute. So just to summarize this session, when you can use GraalVM and for what you can use it. First of all is high performance. If you want to have your application running really fast, you should evaluate GraalVM in JIT mode. If you want to have this fast startup and low memory footprint for your Java applications, please take a look at GraalVM native image, maybe just it, or one of those frameworks that support it. Another one is that if you want to have convenient language interop, and it can be not only crazy cases like doing many languages at one time, but maybe you'd be interested in having your application written in one language, but you also may need this one library from another language. So that could be a good case to use GraalVM Polyglot capabilities. And the last one is it can be easily embedded in various environments, so you can use its languages and features in those environments. So how to get started? You can download GraalVM from this website, graalvm.org, and it also comes with documentation and samples and some helpful command line flags. If you're looking into following the updates, perhaps the best source would be Twitter. That's where we are the most active. And if you want to get help, we have this mailing list, but perhaps the fastest way is that we have this community Slack with our community members and team members, so you can talk to us there. That's basically all I had. I also will be around here today and tomorrow, so if you would rather ask your question privately, I'll be happy to answer. And also, I have GraalVM stickers, so if you like stickers, please come to me and I will be happy to share. Thank you. Do we have questions? Yeah, go ahead.
Is it portable? If I build an AOT image, can I move it from Windows to macOS?
Yeah, I will repeat your question for the recording. So whether or not GraalVM native image is portable. So if you're asking about things like cross-platform compilation, currently, unfortunately, it's not supported. You can try going with, containerized environments. It can be an option, but by default, you would need to build on the targeted platform.
Thank you.
Yep. Yeah, go ahead.
Can you talk some more about the differences between the community and the enterprise distributions?
Yeah, so you're asking about differences between Community Edition and Enterprise Edition. Well, of course, difference is license, right? So licensing policy is different, but functionally, component-wise, they are equal. So if you want to do Polyglot or native or whatever, you can do it with both editions. And also, well, first of all, we want CE version to be fully, functional, but also we want you always to have this option that if you're using an enterprise edition and at some point you're not really happy about it, you can always go back to community edition. So component-wise, they are equal, but there are some additional optimizations that allow you to get even more performance with enterprise edition. So typically what we recommend is that you get both of those, you evaluate both of those, and if you see, because everyone's workload, everyone's application is different. So if you see some very distinct performance improvements with Enterprise Edition, and that is something you are willing to pay for, then yeah, you can go with it. If you see enough improvements with Community Edition, once again, we are happy to see that you can go with Community Edition. Thank you. Okay, I'm staying around, so if you would rather ask your question privately, please come to me, and thank you for your attention.